Servo motors are an easy way to add motion to your electronic projects. Originally used in remote control cars and airplanes, they now crop up in all sorts of other applications. They are useful because you can precisely control the positioning of these motors, instruct them where to point, and they will do it for you. An ordinary DC motor has two hookup wires and simply turns continuously when power is applied. If you want it to spin in the opposite direction, you will need to reverse the power. And if you want to know how far it has turned, you will need to devise a way to measure that. In contrast, you instruct a servo motor where to turn using carefully timed pulses. The servo has three wire powers, ground, plus a third wire to carry command pulses. In the most generic sense, a servo mechanism is a device that uses feedback to achieve the desired result. Feedback control is used in many different disciplines, including speed, position, and temperature. In the context we are discussing here, we are talking about hobby or radio control servo motors. These are small motors primarily used for steering radio controlled vehicles. Because the position is easily controllable, they are also useful for robotics and animatronics. However, they should not be confused with other types of servo motor, such as the large one used in industrial machinery. Servo often comes with multiple attachments such as wheels or levers known as horns that can be attached to the shaft to fit the device they are operating. Most hobby servo uses a standard type of three plug-in with the same controlling signaling, which makes RC servos responsibly interchangeable. The connector is a female 3-pin 1-inch pitch header. One thing that can be confusing is that the wiring color code isn't always consistent. There are several color codes at play. The good news is that the pins are usually in the same order, just that the color are different. The third pin of the servo connector carries the control signal used to tell the motor where to go. This signal is specific type of pulse train. The pulse occurs at 20 millisecond, or we can say 50 Hz frequency interval, and vary between 1 and 2 milliseconds in width. The pulse width modulation hardware available on a microcontroller is a great way to generate servo control signals. Common servo rotates over a range of 90 degrees. As the pulses vary between 1 and 2 milliseconds, they should be at the center of their mechanical range when the pulse is 1.5 millisecond. Internally, the mechanism of servo motor uses a potentiometer attached to the rotating shaft to sense the position. It measures the width of the incoming pulses and applies current to the motor to turn the shaft until the potentiometer indicates that the position corresponds to the incoming pulse width. There is a form of feedback control. The motor has received the desired position from the pulse width, and the actual shaft position is fed back to the circuit via potentiometer. It compares the desired value to the actual value and drives the motor in the direction that causes actual to match desired. Here are the inside of servo that has been discussed. You can see the gears, DC motor, position potentiometer, and a small PCB. The PCB has a chip on one side, possibly a small microcontroller or specialized servo IC. The other side of PCB has some discrete transistors, probably in an H-bridge configuration, which allowed the controller to steer current through the motor in either direction for both clockwise and counterclockwise rotation.